Okay, this is part 2 of section 7.4. We left off on this slide, graphing linear inequalities without using test points. You can use a test point if you want, but it's usually you can kind of logic your way through this. Remember, if you have a vertical line and x equals a number, let's suppose you have x equals, 5. Okay, it's going to be a vertical line at 5. If you have x is greater than 5, or greater than or equal to, let's do greater than or equal to 5, still going to be a vertical line at 5. Now, you can do a test point. You can choose 0, 0. You can plug it in. Is 0 bigger than 5? No. So you would not shade over top of the 0, 0. You'd shade on the opposite side. But if you think about it, we want our x values to be larger than 5. Well, larger than 5, is that going to be on the left side of the line or on the right side of the line? On the right side, we have 6 and 7 and 8 and 9, which are numbers that are larger than 5. So, can you do a test point? Yes. Can you do this without doing a test point? Yes. Same thing with a horizontal line. Remember, with a horizontal line, it's going to be y equals a number, or in this case, y is greater than or equal to a number, y is less than or equal to a number. And again, you can do the test point if you wish, but it's not strictly necessary. Most people can kind of logic their way through it. Graph in each inequality. So we have y is less than or equal to negative 3. Since this is a y value, it is going to be a horizontal line. Since it's equal to, it's going to be a solid horizontal line at negative 3. Now the inequality says we need numbers that are smaller than negative 3. Smaller is lower or down. So to be less than or equal to negative 3, we would want to be underneath this horizontal line. You're going to shade below. Again, you can do a test point, but it's usually not necessary for these horizontal and vertical lines. Okay, for part B, we want x is greater than 2. It's going to be vertical. And since it's greater than, it's going to give us a dotted line. We need numbers that are larger than 2. And larger than 2 are going to be on the right side, so we're going to shade on the right side of the line. For word problems like this, I don't want you to write it down. I don't want you to copy it down, just like I wouldn't want you to copy it down in class. We have the graph. It has 3 kinds of regions. We've got the desert, grasslands, and forests, and their temperatures. We've got T is greater than or equal to 35, and precipitation, which is P. Show that a point A is a solution of the system of inequalities that describes where forests occur. So what you're going to do is you're going to get your point A. You're going to figure out the coordinates of point A, and you're going to plug it into the equation for force. The coordinates for point A are the point 50, 30. Since your x value, so to speak, is the temperature in Fahrenheit, an x value of 50 would indicate a temperature of 50 degrees. And your y value is P, or precipitation. So a y value of 30 means 30 inches. So in order to do this problem, we need to show that this 50-30 satisfies the system of inequalities for the force. We're going to take 50 and substitute it for T, and 30 and substitute it for P. So a forest occurs when the temperature is greater than or equal to 35. So if we take 50 and replace our T value, is 50 larger than 35? Yes, it is. Now we also need, for this equation, let's go back to here, right here. We need for that to occur. So we're going to take 50 for T and 30 for P and substitute it in and see if that works as well. So multiply 5 times 50, we get 250. 7 times 30, we get 210. Subtract, we get 40. And is 40 less than 70? Yes, it is. Since it works for both of them, we say that it satisfies the system for force. To be a solution to a system of inequalities, it has to be a solution to every inequality in the system. We want to graph the solution set of this system. We have x minus y is less than 1, and we have 2x plus 3y is greater than or equal to 12. In 7.3, we had a system of equations, and what we were looking for is where the two lines crossed. Well, it's going to be a similar sort of idea with this one. We're going to graph this inequality. We're going to shade it. We're going to graph the second inequality and shade that. And instead of looking to see where two lines cross, we want to know where two shadings cross. So let's do the first line. X minus y is less than 1. First thing you want to do is pretend that that is equal. Since it's standard form, we're going to plug in 0 for x and 0 for y. If we plug in 0 for y, we get x equals 1. If we plug in 0 for x, we get y equals negative 1. And you can check that. So you have the point 1, 0, and 0, negative 1. That's less than, not less than or equal to, which tells me I need a dotted line. Test point. Since that line does not go through 0, 0, I'm going to choose 0, 0 as a test point. Is 0 subtract 0 less than 1? 0 subtract 0 is 0, and is 0 less than 1? Yes, it is. So lightly, I'm going to shade over top of 0, 0. Lightly. You are going to have to erase. So you might want to use pencil. It's a good idea to use pencil on these. Second inequality, got to graph that too. Again, it's in standard form. plug in 0 for x and y separately. So I plug in 0 for y, I have 2x plus 3 times 0 equals 12. Remember, when we're doing our points, we want it to be equal. 2x equals 12, or x equals 6. For my second point, I'm going to plug in x equals 0. 2 times 0 plus 3y equals 12. 3y equals 12, or y equals 4. So those 2 points, I have 6, 0 and 0, 4. Okay. Go back to the inequality, and you see that it's equal to, greater than or equal to, so that I'm going to draw with a solid line. Since my line does not go through 0, 0, I'm going to choose 0, 0 as a test point again for the second inequality. So you're going to plug in 0 and 0 at the same time. 2 times 0 plus 3 times 0. Is that larger than 12? So we have 2 times 0, which is 0, 3 times 0, which is 0. So is 0 bigger than 12? No, it is not. So this time I'm going to shade away from the point, or on the other side of the line. So I'm going to shade up here. Remember to shade lightly, because you are going to have to erase. Now, to get the actual answer, remember with the system of equations, what we were looking for is where the two lines crossed. Well, for this one, we're looking for where the two shadings cross. If you look on the right side, all I see is green. In this region right here, there is no green and blue, so I'm going to erase that because that's not part of the answer. If you look on the left side, you only see blue, not green and blue, so you're going to erase the blue. So the answer then would be where these two shadings overlap. So this is going to be your answer. If you don't use pencil, you can still do this with pen, but make sure you shade the answer region darkly. So you can use pen, but you have to shade darkly. Okay, the homework for section 7.4 is going to be 4 through 36 every 4. I also want you to do 45 and 46. And this is the end of part 2.